Okay, in this presentation we are going to introduce non-parametric tests, and we'll start off with a simple test called the sign test, which is based on the binomial distribution. So, a psychologist claims that visual memory is more effective than oral memory, which is memory to do with hearing. To test this claim, 10 students are selected at random and examined for visual and oral memory using a standard memory test. For each student, the psychologist notes whether his or her oral or visual memory score is better. So we have two states here, A and V, and we want to know for each student they're classified as A or V. Okay, so we have 3 who are classified as A, which means that their oral score is better than their visual score, and we have 7 whose visual score was better than their oral score, so we're classifying them as V. Carry out a suitable analysis of these data to investigate the psychologist's claims and comment on your results. So this is a binomial sign test, or sign test actually, because it's sort of what we're going to do is model it as a binomial experiment, and we're going to look at the sort of the signs. Okay, now essentially what we have here, V and A, is essentially they're equivalent to plus or minus depending on which is better, but essentially we have 2 categories. Okay, A and V. So it's a binomial, it can be classed as a binomial experiment, and we don't really worry too much about the name, the sign test here, but actually it implicitly suggests a sign, a negative or positive score. Okay, so the null hypothesis is that A and V are equally likely. Okay, that for the general population we should get a roughly the same amount of children who are both A as V. Okay. So here, hence the number of A's is binomial with a parameter with parameters 10 and 1/2, as is the number of V's if the null hypothesis is true. Okay, so if we were to perform this experiment an infinite number of times, that we would get roughly, on average, 5 and 5 for each experiment. Okay, so we get 7 and 3 in this experiment. We might get 4 and 2 in the next, or 4 and 6 in the next. 6 and 4 in the one after, and the opposite odds, and overall for the general population it works out to be 5 and 5 per each batch of 10 students. Okay, that's the null hypothesis. The alternative hypothesis is that V is greater. Now that actually has importance later on. That means it's a one-sided test. Sorry, I actually stated here. A one-sided test is therefore needed. That's particularly important when we start looking at the tables. Okay, so there's special tables, statistical tables, that we would use, and the important thing about that is that we have to be careful how to read the tables, because they're sort of formatted for a two-sided test, so we have to adjust our approach accordingly. Okay, now these are the tests that are essentially how we calculate the p-values. Okay, for a certain threshold. Okay, here we're going to work on the basis of, well, actually, it doesn't really matter one or the other, because A equals 3 or B equals 7. So we can let K equal to 3, and then go less than or equal to probably N less than or equal to K, and then otherwise K equal to 7. So we should get the same p-value in each case. Okay, so we're going to use, actually I can't remember which one we used. The top one here. So it does actually format with how we specify the alternative hypothesis. Okay, but mathematically the other one is also the exact same. Okay, so this is what we're going to do here. By the way, this is a simplification of the binomial distribution, the probability density function, or the cumulative density functions. Okay, so yeah, actually, when you work it out, you'll realize it pretty quickly. P and N are P equals Q in these cases 0.5 or 1/2, and that is where we get this half here. Okay, so anyway, probability of n greater than or equals 7. So essentially, what we're going to do is calculate our p-value. So 10 choose 7 plus 10 choose 8 plus 10 choose 9 plus 10 choose 10 times 1 over 2 to the power of 10. Okay, and here 10 refers to the 10 students. So essentially working that out, we get 120 plus 45 plus 10 plus 1 times 1 over 2 to the power of 10. Working that out, we get 0.172. Actually, I think it is, having done this, used these numbers before, I think you might get the answer closer to 0.1718. What you can do there is actually use R or something like that, the programming language R, to figure that out, if you want to check your answers. So in this case, this is our p-value, and our p-value, we're comparing this to 0.05, using that as our significance level. We weren't told a significance level, so just in the absence of a significance level, we use 0.05. Essentially, the p-value is not less than 0.05, so we fail to reject the null hypothesis. So there's not enough evidence to reject the null hypothesis. Basically, 10 students, a sample size of 10, to make generalizations about the population just won't work. Now, really what we're trying to do here is actually just introduce the test. So it's a sort of non-parametric statistics test 101. So there's another part to this where we get into a procedure that we would use more often. What I'm going to do is actually pause it here and start a new video.